Hey everyone, welcome to this Facebook Live. It is Thursday evening, just before 9 o'clock.
Heck yeah, almost
8:34. It is. It's almost Friday.
Thank goodness.
Friday couldn't get here fast enough, but it's been a little bit of a rough day. A lot of technical issues behind the scenes.
Oh
A
man,
lot
yeah.
of things not working. But this guy right here, Peyton Langford, put together a blog all about severe weather forecasting. We're going to dive into that. We're going to take a look at that. But I know you got a lot of questions. We do have a limited time because we have a 9 o'clock newscast. There's always another newscast that's coming.
Yeah, not enough hours in the day.
Yeah, that's for sure. We need to add a few more. And I know a lot of you are wondering about the cell service that dropped off. Let me know. Comment if you experienced a lack of cell services. I was driving my son to school and I was like, oh, what button did I hit? I think I hit something on my phone because it said SOS.
Oh, yeah.
And I know that's when you don't have any cell service, but I thought I might have turned something off because oddly enough, my phone was in my pocket and it was still essentially, still lit. Like
Yeah.
it wasn't in lock. So I might have thought I hit something. Contrary to belief and contrary to what you have seen on social media and a lot of posts that are out there, this was not because of the solar flares, the X-class solar flares that took place over the last 24 hours. In fact, there were 3 X-class flares with the newest one this afternoon, which is an X6.37.
Yeah,
So
that's a lot.
That's
a
a
little bit
very
different
strong
than the ones that came.
X-class solar flare. Yeah, it is not a gradual, what we call linear.
How long do they take to get here?
They take typically about 2 days. However, the flares happen pretty quickly. It's the CMEs, but the CMEs essentially, coronal mass ejections don't always come from solar flares. So solar flare, if it's strong enough, will lead to a radio blackout and shortwave wavelengths. You know about that. Shortwave radio.
Yeah.
Can you explain a solar flare deal? Yes, I can. And I know there's a lot of talk about that. I've got a little bit of a loop from the Solar Dynamics Observatory. And this, by the way, is our sun. Yeah, make that full screen. Here we go. So check this out. How cool is this? This is our sun. And our sun is essentially, it's a pretty active star where there's a lot of explosions that are going on. There's a lot of magnetized areas where you have sunspots, and you can see where Peyton is moving the cursor over. Those are called coronal loops because the sun's magnetic field, sometimes positive and negative, what happens is when those snap, you get a release of energy and essentially an explosion. The explosion is what releases, you could see those bright areas, that energy. And so that's essentially the sun and the magnetized field in the sun that's erupting. Now, the thing is that you have to get an ejection of plasma. So that is the coronal mass ejection that shoots out from the sun. And astronomers and sun scientists are saying, essentially, scientists are saying that this is not essentially producing a very large coronal mass ejection, even the 6.37. So, anyways, that's what that happened. And this did cause solar blackouts on the other side of the planet. See, outage side of the planet at the time of the outage.
Yeah.
So but the solar flares don't interfere with at the surface cell phone signals.
I
So
saw one theory, I guess, would be it disrupted the satellites, but most of the internet nowadays is like fiber optic cables.
now, yeah, it did mess with Starlink though. I did hear about that. No, we have not talked about the alert day potential for Tuesday. We will. My phone did not have service. I know mine did not either. But anyways, isn't that kind of cool? And so this is a very bright sunspot, 3950, I want to say, or maybe it's 3590. I can't remember now anymore. Go ahead and escape, and we'll bring that back up. But I want to say it's go to spaceweather.com. I'm trying to remember here. I want to say it's 3590. I'm going to say. Yeah.
Oh my gosh, can't spell.
That's all right. and click on that. It's 3590. Yeah.
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 Nice.
3590 is the sunspot. So check this out. This is what it looks like right there. You can see that giant sunspot.
You can actually see it with your own eyes. Too,
Yeah,
right?
we weren't able to look at it today because of all the cloud cover and the storms. But to make a long story short, that's what it was. That's a very large sunspot that can release more X-class solar flares because of the magnetized field. The beta gamma delta magnetic field that it harbors is essentially strong enough to release another X-class solar flare. So we know that. I'm on AT&T and I had issues. I had issues basically all afternoon. So, but it wasn't solar flares. Something was up with, and we don't know. We haven't heard the reason for that. So contrary to belief, you tell someone now it wasn't a solar flare. Solar flares can cause disruption of, shortwave.
Ham radio.
Yeah, ham radio. Absolutely. Radio blackouts. Different deal, though, with cell phones. It was absolutely coincidental.
Yeah, just a weird coincidence.
Yeah. So that's that. Let's get to the weather forecast and take a look at what we've got after we look at the beautiful star in our solar system, the sun. All right. Here's the 2-day weather forecast. Got to let you know about that. We've got no storm chances, unlike what we saw this afternoon. Those storms are out of here. Everything's gone. Here's a look at the River Valley forecast. As temperatures will be a little chilly tonight. In fact, you can see the front, and you can feel the front coming through, and that dropped the temperatures a little bit. River Valley won't be as cold, but we get around 70 degrees and lower 70s. And so I know a lot of you are wondering about the severe weather potential. Just wanted to give you the forecast now. Now we'll dive in for the next 15 minutes or so and look at our severe weather potential. Now, I know you guys want to know exactly the details. What time is this moving in? Will it hit Rogers? Will it hit Bentonville? Will it hit Fayetteville? Here's the deal. We can't tell you that far out. We really honestly can't even tell you that far out a day in advance. We can't even tell you that it's 12 hours in advance.
Yeah, that'd be pretty tough.
It's tough. But we can tell you that the pattern is favorable for severe weather, and we can also tell you that the Storm Prediction Center has issued a day 6 severe weather outlook. It's been a long time since I've seen a day 4 through 8 that's essentially this large, that has this amount of area that's covered in severe weather potential. All hazards will be possible, but as you'll see, there are some things that make the severe weather predictions rather low in terms of confidence right now. And
so there's only so much we can look at.
You're smiling because I know you did a blog on this, and it's all about the jet stream. We can go ahead and bring that up because I'm going to lead into that. But there is the area that Zach, Peyton, and I and Josh have been watching, and it's a rather large area. I personally thought this would be outlooked on a day 7, but there was still a little bit of model uncertainty, and so essentially, no, not the case. That's a look at the severe weather threat. Now, this, by the way, outlook is for Tuesday morning into Wednesday morning. So what happens on Wednesday? Well, this risk is going to shift eastward. So we got severe storms possible for next Wednesday. And notice how that shifts east. Now, keep in mind, this could change. This could back up, move westward. You know how forecasts are adjusted and things change. All hazards possible. This could shift east. Stay tuned. Why is there so much uncertainty? Well, here's the giant low that's off the west coast of the United States. But the problem is that there's also energy that's to the north. And this is where the models have a tough time discerning how much energy this northern energy is going to pick up the southern spin in the atmosphere.
It's going to be a chain reaction because you have that big spin, you have that high angular momentum, which I talked about in the 7 o'clock newscast.
You did, huh?
And
nice.
You got the southern energy. So you have these 3, I guess, weather systems, if you will, that are going to be interacting. Who's going to win? What's going to happen? Who will absorb who? That remains to be seen. That's why it makes it so difficult, because that is kind of what dictates a higher confidence in what's going to happen until this system moves on land.
That's right. And you're going to see right here, look at that. That is a lot of almost zonal jet stream flow where it's very basically elongated. Think of a rubber band. You got a rubber band, and as you're stretching it, it's straight. But what happens when you let it go? Snap. It snaps back, and it goes like this. So it goes like this kind of form, and then it goes choom like that. That's what a rubber band does when it snaps back. So guess what? That's what the jet stream is going to do. And we're going to talk about that here. But let's go back to this full screen. We want to go back to that low pressure system because this is key. So we're going to look at this. There's the spin in the atmosphere that's west of the United States. And so you look at that and you're like, wow, that's a massive low pressure system. However, that's not all the energy, as you'll see. So there's the giant low, and you can see it churning. Now, the reason it doesn't move on shore is because there's a ridge of high pressure. And you can see this ridge that's building, and high pressure dictates where low pressure goes. This is where the jet stream rides up and over, essentially. So when the jet stream rides high, the weather will be nice and dry. When it dips low, thunderstorms come and go. So there's a little rhyme that you can remember. Now, look at this. As we go back here, there's the low pressure system, but look at what's diving into the Pacific Northwest. There's that zonal jet stream flow that buckles, and then look at how that drops southeast. Now, we're going to pause it right here. This is where the European and the GFS differ greatly, because the GFS actually takes all of that energy and combines it into one system, whereas the European is lagging this low back a little bit. So guess what? This doesn't get pushed. This doesn't get kicked to the east. It stays to the southwest. And so you're going to see that low right there. This low moves into the central United States. This one misses it, so it doesn't get kicked. Then it races east. Now, look at all the energy is focused in the Great Lakes region. We get this very little bit of energy, but we still have this low off to the west. So if I'm looking at the European model, I'm going to guess that it has rain on Thursday, and you can see that energy flinging overhead. So that is the European model. Oh, and by the way, next week, if the European comes to fruition, that's trouble right there. Yeah, I don't know if you saw that or not, but that's a very large trough of low pressure.
Whoa.
And so, anyways, now let's go back to the European or to the GFS model. So we're going from the European to the GFS. These are, right, by the way, about the only really good long range forecast that I can show you on this weather graphic system. So let's go ahead and show this again. So we've got vorticity, the amount of spin in the atmosphere. We got this giant low off to the west, and we're going to step through this here so you can see what's going on. So there's the giant low. See, it's still off to the west. There's going to be some high clouds because of those little pieces of energy. Now watch. So here we are, 10 o'clock on Monday in the evening. We've got, this system that looks like it appears it's getting picked up by this low because it digs farther south. And then just because it's a little bit farther south, this gets kicked eastward. Now, the models are going to struggle with all of these little pieces of energy. You see these little red dots right there. These are all spins in the atmosphere. And I like to have a saying, it's the small stuff that makes the big stuff happen.
Yeah, for sure.
The reason that is because the small stuff might be a little bit of lift where you get thunderstorm development. But if you have a massive trough, then you get a lot of thunderstorms, and it's cloudy and it rains ahead of time. That drops the temperatures, and that lessens the severe weather potential. So that is what we want, but it's the small stuff that makes the big stuff happen. Now look at this. Tuesday, we've got a conjoining of those systems as they move eastward, and they both are essentially the same piece of energy. There are a couple different pieces, which is why on severe weather days, you can get thunderstorms in the morning and then additional storms during the afternoon. Now that is a lot of energy. And that is a lot stronger and a lot farther south than the European model. So there's your differences. So now, here's what I present to you. Which one of those is right?
Well, yeah, it all depends on
That's
how deep the trough actually digs. Which depends on how big the ridge builds over us before the system, because that'll dictate how deep the trough digs. If the trough digs deep enough, then it'll be like a magnet. When you get two magnets close enough together, they eventually attract.
Yeah.
But I just don't think it's gonna dig that deep. Who knows?
You don't. Okay, so I don't know what it's going to be.
Yeah, I don't know.
And we don't know either. And that's why we can't give you all those details. You saw how complicated that was. You saw how much is going on. Now let's talk about the jet stream, because this is Peyton's wheelhouse right here. But we're going to look at the jet stream, and you're going to see a big trough of low pressure swinging in. Now, if you see this, this is a lot of jet stream energy. And no doubt, we're talking a very strong temperature contrast at the surface. This is a very stout front. There's a lot of energy. We know there's instability, but there's that jet stream energy moving in. Now, if you look at this, there are points and basically areas of the jet stream that are more favorable for rising motion and less favorable for rising motion. So we're going to get into that in jet quadrant theory, but let me go to Peyton's weather
It's a
blog.
theory.
Yeah, jet quadrant theory. Yeah,
I know it's a theory.
that's what it's called. Jet quadrant. I guess it was the theory back when I was in school. How about that? All right. All right. Always showing my age. But this is Peyton's weather blog. And I urge you, if you want to geek out about the weather, because we won't be able to dive into this as much, go ahead and check it out. But we're looking at different types of jet streaks. So you got, whoa. You're I'm on there already. All right. All right. We're going through that really fast. I was like, whoa, that's a lot going on. All right. So first of all, we're starting off with the jet, and you can use the cursor. So this is what the jet stream's looking like from the GFS. Now, remember, the GFS is deeper. It's stronger with that system. You can see all those colors that are over the area. On the eastern side of that trough, you've got a ridge. And you can read all this if you want. But essentially, the trough is what we're interested in. The trough axis at this point is running from bottom left to upper right, which means it's a positively tilted trough.
You're also on the
This
left
is
side of the
all
bridge,
talking
too.
about Tuesday, Rob. And yeah, right, too far out to forecast. That's what I'm saying. All of these things that come into alignment and that you can't predict 5 days out, 6 days out. Now, you know the potential's there because you can see the basically the long range pattern. So scroll down and show the areas where rising motion, and Peyton, you go ahead and describe this.
Yeah, so this is kind of the trough we're looking at. And if you split it in half, on the right side of a trough is what we're focused on. So if we go back up here, the right side of this trough axis, which is the dividing line, is what we're focused on. That's where you're going to see more upwards motion. Conversely, on the upstream side of the left side of a ridge, that's also where you're going to see more rising motion. So we got cyclonic, which is counterclockwise flow, and anticyclonic, which is clockwise flow. So this is the ridge, this is the trough. So you can see we're kind of in a big area of lift. So highlighted that here on the jet stream, downstream of a trough, upstream of a ridge. This is where you're going to have a lot of rising motion.
Yeah.
But then you got to look at the 4-quadrant jet streak, which apparently is a theory. Maybe. Who knows?
Go check it out.
We'll come back to that.
Yeah.
But if you divide the jet streak, which I do so here, you will see that in the quadrant 2 and quadrant 3 are where you're expected to have favorable areas of stronger lift. So these are areas of enhanced strong lift. The red area is still going to see a good amount of lift because you're still downstream of a trough or upstream of a ridge. But the green areas are where you're likely to have that stronger lift. Of course, this is a forecasted jet stream. So we'll have to wait to see what it actually looks like.
So there's a chance that jet stream is a lot farther south, which would put us in a different quadrant, which would change the forecast completely. So yeah,
shifting these around will definitely, or could definitely change a lot what we see. And another thing to look at is moisture.
Yeah, we've got that in the mid levels. We got that in the low levels too.
Yeah, so that's pretty much the only things we can look at because that gives us the only idea for strong lift is moisture and the upper air analysis. Because once you start getting really low, then you get it becomes a lot difficult for models to handle. And of course, they don't go out that far because they're focused on higher resolution, so they sacrifice time. But for long range models, that's pretty much the only two things you can look at right now is upper air stream because there's not as much advanced equations for the computer models to handle, so they're a little bit more accurate, and moisture.
And that is geeking out right there. That's big time geeking out. As I told you, we would geek out. But now we got to get back to the actual forecast. So this is all playing in a role to the forecast. Now this is the GFS model, which is what we showed with the blog. But you're going to notice that it does get a little bit stronger as it kicks in. And look at that right there. Wednesday, we're actually probably in the right. the left exit, which is the greater rising
Yeah.
motion.
And it also seems sort of to get a negative tilt,
Yeah.
which a negative tilt would create areas of super strong winds. Just as it tilts, it's like prying open something with a crowbar. You get a lot of force and a lot of tension right there at the end of the crowbar when you're trying to open something. And once that opens up, you can just fire up a lot of storms.
That's right.
So that it adds a lot of support for strong storms and super strong winds.
So go ahead and check out Peyton's weather blog right here. Just you can go to basically our app. It's on there. You can go to social media, which is where we
It's
have
everywhere.
it. You probably won't see it on your timeline though, because Facebook stinks.
Or you'll get a notification 3 days later.
Yeah. And then the storm's already over.
Yeah.
All right, real quick. This is what we're forecasting. We are expecting severe weather potential. There's just too much energy. Put it this way. The models, they struggled on storm development today. There were storms a lot in Northwest Arkansas, and the models did not have that. They also didn't yesterday have the storm activity in Southwest Missouri until last night. We had an idea there would be storms. It doesn't know the area. We can't get that even 12 hours out. It's just impossible. So just like when you're forecasting solar weather and northern lights and the KP index and all that, that's just as hard, if not harder.
Yeah.
So there's a look at remember, that European model is faster because of the upper level energy doesn't absorb the system that's southwest of California. So coincidentally, it's out of here by Wednesday afternoon. Goodbye. See you later. Good riddance. But then that second bit of energy comes in on Thursday. So does the GFS show that? No. The GFS shows it moving out by Thursday, but it does have more thunderstorms popping up Tuesday night and Tuesday evening. I personally think Tuesday evening is going to be the trouble time for us.
Yeah, we're probably going to see a lot of clouds early like we did today. And then eventually we'll get a lot more heating. Pop that lid off the boiling pot of water, and you're going to see some explosive thunderstorms.
Yeah. So here's a look at some cold air, too, behind this system. So be ready for that. And then it moves east pretty quick, but, it's going to be a stout northerly wind behind that system, and it's going to be breezy. But remember that European model had the southwest low coming in, and the GFS has absolutely nothing. So there's your difference right there. When you're forecasting for Thursday after the severe weather, what do? Do you go with the European, or do you go with the GFS, or do you just go, you know what, there's a chance, but we're not sure. So now we got to look at ingredients. We know the energy's there. We know the jet stream's going to be there, but we also know that there's going to be wind shear and there's going to be instability. So this is the energy helicity index. That's pretty high, folks. And that's Monday evening. But you know what? We have to include another thing that's in the forecast, and that's the cap.
Yeah. Did we try to explain the energy helicity index?
So energy helicity index, this is really easy. It's just the amount of fuel that's available for the thunderstorms and the amount of spin that those storms can have. I think that's a real simple explanation.
Yeah. Cape and wind.
Yeah. It's just cape and the wind shear, if you will. Because what helicity is, it's a measure, it's a quantification of the wind shear, the wind speed and wind direction with height. But look at that. That's Monday evening when there's not even any storms. Because the cap is there, we don't know if the system's coming through. But now here's the European model. Guess what? Still has that stuff on Tuesday. Then it kicks it out really fast Wednesday, and then nothing else comes in after that. Here's a look at Monday. You can see the energy lifting northward, but the GFS has a little less, and that's because it's struggling, me personally, with the instability. Yep, you can turn on the lights, and we'll kick it off. But so anyways, that's kind of what we're looking at. So stay tuned. Probably another X-class solar flare coming from Sunspot 3950.
Probably going to come, Saturday? Maybe Friday?
We'll see if that coronal mass ejection even hits us or if anything. So that's that. The severe weather potential is there. If you're just joining on, our last thing we'll show you is the risk. Now, this is a very large risk. Very large risk for a day 6. I mean, and you can see that we are basically right in the heart of that. So, yep, we got a 9 o'clock news, and it's about to start right now. And so there's Anna Darling getting ready. in the back. Yeah, we also have Kayla Cade about to give her first story. And so there you go. 15%, 6 days out. It's crazy. That means the confidence is there for severe weather potential. Just don't know all the details. And the reason it's so large is because of the uncertainty exactly where those storms will be.
But read that blog.
Yeah, read the blog. It'll help you understand severe weather forecasting. And we will see you tomorrow with more details as we get closer. So watch Fox 24 News at 9, which is starting 10 seconds. 9, 8, 7. Oh,
Maybe sooner.
we'll see you. Bye.